session. I hope anybody who did see that also sees this. So I was saying to them, uh, I tried my hard to give the best actually. So it is of, I think, approximately 50 slides. It took about 40 minutes. See this is, see here, see, this one is 83 slides, which means it takes a lot of time, so I should complete very fast, you know. So I'm covering from basic level to JEE mains level. By seeing this you can answer everything, I hope, I wish. Yeah. So see, one more first, today's topic is chemistry mole concept, some basic concepts of chemistry. It is also known as, this is mole concept. This is the second chapter for today. Actually, I should complete 12 chapters today, by the end of today. At any cost, I'll update all the 12 chapters revision today. That's my challenge for today. Okay. So for now, mole concept. See, I don't waste much time. See, one mole is defined as number of atoms present in 12-gram carbon. Okay, I hope you did understand. I'll explain you again. One mole is nothing but number of atoms present in 12-gram carbon atom. See, one mole is nothing but Avogadro number of atoms. See here, 6.022 into 10 to the power 23, which is nothing but Avogadro number is denoted as Na or No. Now number of moles. For the formula for number of moles is number of unit particles upon Avogadro number. See, Avogadro number 6.022. Give me a minute. 6.022 into the 10 to the power of 23. Now gram atom. In JEE, especially JEE main, many questions it will be given that gram atom, but you should not be tense. I didn't see this type of question, how to solve. So gram atom is nothing but mole. Suppose in the question they gave us like 5-gram atom of sodium. In the question somewhere a phrase, 5-gram atom of sodium is used. That means 5 mole sodium atoms, which is 5 into Avogadro number of sodium atoms were given in the question. Oh, okay. Hope you did understood. Also gram molecule. Gram molecule also refers to the same. Gram molecule means nothing but mole. See, in the question it was given that 10-gram molecule CO2, some phrase was took, and here 10-gram molecule is nothing but 10 moles of CO2 was used. Here see, 10-gram molecule CO2, in 10 grams of molecules of CO2, how many oxygen atoms were present? Let's think of some question. Let's solve some question. See here, 10-gram molecule CO2, 10-gram molecule, 10 mole CO2 will be present. 1 mole CO2 has number of CO2 molecule. Yeah, now observe, 10-gram molecule is nothing but 10 mole CO2. Here 1 mole CO2 is equal to number of CO2 molecules. 10 mole CO2 is equal to 10 into Avogadro number of CO2 molecules. I hope you understood. See, 1 mole of CO2 is nothing but Avogadro number of CO2 molecules. 10 mole CO2 means 10 into Avogadro number of CO2 molecules. 1 molecule of CO2 means, in this, oxygen atoms 2. So 10 into Avogadro number of molecule means 2 into 10 into Avogadro number, which is 20 into Avogadro number of oxygen atoms were present. Hope you understood it clearly. Okay, let's quickly get into the next slide. See, the number of atoms in 8 grams of sodium is x into 10 to the power of 23. The value of x is asked. See, sodium's atomic weight is 23 and atomic number is 11, right? See, 1 mole of sodium is nothing but 23 grams of sodium. In 1 mole of sodium, Avogadro number of atoms were present. So 1 mole is nothing but 23 grams. 23 grams of Na contains Avogadro number of sodium atoms. That means 1 gram of sodium contains 6.0 Avogadro number upon 23 number of sodium atoms. That means here in the question we were asked about 8 grams of sodium. So 8 grams of sodium contains 6.022 into 10. That is Avogadro number by 20 upon 23 into 8 grams. So these many number of atoms were present. But here we were asked for the nearest integer. So the value of x will be C 23 uh, 6 8 48 approximate 48 upon 23, which results in 2. Okay, that's how it should be calculated, because we are asked to find out nearest integer. Okay, so this is the answer for this question. Next, the very important thing you should know is uh, there are many physical quantities given to everything. Like, see, if you are walking on a road, you will go 1 kilometer, you will measure the road in kilometer or some meters, or in abroad it is measured in miles actually. So in it was calculated in miles. So for atom also there is a particular physical quantity introduced to make the atom calculations easier. So that is nothing but atomic mass unit. Okay, see, it is represented as AMU or mu. You all know mu symbol, right? See, this mu, atomic mass unit or mu. Here atomic mass unit means 1 by 12th of mass of one atom of 12 gram carbon. C12 is nothing but 12 gram of carbon, which means one atom of uh, actually, you know, isotopes, right? For some isotopes carbon will be 13, carbon C13, C14. It may be existed in that state, but here to mention clearly 12, the atomic weight 12, this atom of carbon 12 is used here. See, 1 AMU is nothing but 1 by 12th into mass of one atom of carbon 12. Okay. Also, there is a relation between AMU and Avogadro number. This is revision class, so we should not extend it big. So to finish it off fast, see, 1 AMU is given as 1 by Avogadro number grams. Okay. 1 AMU is nothing but 1 by Avogadro number of grams. See, Avogadro number is represented as N naught or Na. In any way can be represented. Okay. See, next concept, let's get uh, molar mass. Molar mass is nothing but molecular mass. Molecular mass unit is gram per mole, gram per mole. The reason already I am using annotated slides was I was not able to write in a good manner with this equipment present for me right now. So I am using these annotated notes. See, mass of 1 mole of substance. Molar mass is defined as mass of 1 mole of a substance. For suppose let us take sodium 1123. So in this case also, here it was clearly mentioned because of many isotopes will exist. You should particularly mention the elements atomic weight and number. Okay. See, here one atom of sodium contains 23 atomic mass units. That means 23 AMU. One atom of Na weighs. That means 1 mole of Na, we also have relation. 1 mole of Na has 23 grams, right? See here, 1 mole of Na, which is nothing but 23 grams of Na, right? One atom of Na means 23 atomic mass units. should make it simpler actually. See, 1 mole means 23 grams, right? Like that, for atom also, atomic mass units, the physical quantity is introduced, I told you, no? So 1 atom means 23 mg, 1 mole means 23 grams. So uh, this is the unit of this one, this is the unit of this one, okay? Also, other main relation where JE questions will be asked frequently is number of moles is equal to given mass by molar mass. Given mass means in the question the mass of what some compound, some x, let's say the compound is x, they'll give the weight of that, so it's called given mass. And molar mass is nothing but molecular mass, 1 mole of that substance made mass of. So number of moles is given as given mass upon molar mass. For let's say CO2, we were asked to find out, uh, 22 grams were taken in the question, 22 grams of carbon dioxide were taken, and we are asked to find out how number of moles. So in order to calculate number of moles, here see, I'll clearly wait, let's strike it off. Okay, let's take green. See, carbon dioxide was in the question, 22 grams of carbon dioxide was used for something. In the question a phrase was taken, like, right? Carbon dioxide is 22 grams. Now you are asked to find out number of moles of carbon dioxide in that particular question. So to find out, see, you are having carbon dioxide as 22 grams, right? That means first you calculate molar mass. How we calculate molar mass? Carbon's atomic weight is 12 into 1 plus oxygen's atomic weight is 16 and the number of moles are 2 here. 16 into 2, which is 32 plus 12, which is 44 grams. So I'll mention here, see, in the corner, right corner above, 44 grams the molar mass is, okay? Let's take it. Oh, sorry, let's write it again, no props. 22 grams and 44 grams is the molecular mass we calculated right now. So number of moles, I'm writing like this, number of moles is given as given mass is 22 grams upon molecular mass, molar mass, which resulted in 44 grams, which results as in 0.5 mole. Okay, did you understand it clearly, in a clear manner? That's what. See, number of see, this is a quick revision of up to what extent we covered till now. See this one, only concentrate this. With this table you will be solving every question, every basic question coming from this chapter and JE means. Okay, listen carefully. So you are given number of unit particles. Unit particles are nothing but some, like, number of atoms, number of molecules, number of ions, everything is considered as unit particles. Okay, hope you did understood, right? So number of unit particles, here number of moles, here mass in grams. So the relation is, for you are given number of unit particles and you need number of moles. Okay, then you should divide it with Avogadro number, and you are given number of moles, you are asked to calculate number of unit particles. then multiply with Avogadro number. See this one. See, from moles to unit particles, you should multiply with Avogadro number, and from your given unit particles you are asked to find out number of moles, then you should divide it with Avogadro number. So this is the first most relation, and the second most relation is you are asked to find out the mass that was took in the question. We don't know the, we are not mentioned the mass, and we are asked to find out, we were given number of moles. From number of moles, if you multiply it with molecular mass, which is molar mass, then we obtain mass, given mass. That means the mass of some substance taken in that particular experiment, in especially in that question. We will be given a question, right? In that question, some amount of that substance will be taken, so that is called molar mass. So sorry, that is called here mass. So we are given number of moles and we were asked to find out mass. So we will be calculating it by multiplying it with molar mass. But we were given some CS. See, we got CO2 in that question. In that question we were given 22 grams per taken. We were asked to find out number of moles. Then what we should do? We were given 22 grams, which is mass. See see mass was given. Mass was given here. See blue color where I am circling it. Mass was given here in the question. We are asked to find out number of moles. Then what we should do? We should divide it with molar mass. See here. See this direction. Molar mass. Okay. So 22 by molar mass of carbon dioxide is 44, which resulted in 0.5 mole. Yes, am I right? This is the way we solve question. So these are the important things. Okay, I'll clear everything and see. You can take screenshot of this. Okay, this is the thing. Number of unit particles were given for calculating number of moles. Yes, I hope I am making much time. I'm taking much time. Okay, I hope everybody understood. I already explained. If you didn't understand, you please play it backward and then listen. Okay, now more in this more concept, ideal gas equation should be learned. This is must and compulsory. See, here we were given that PV is equal to nRT. In an ideal gas equation, everybody know what is ideal gas. Actually, a gas which obeys ideal gas equation is known as ideal gas. Okay, so what is ideal gas equation? PV is equal to nRT. So here P refers to pressure exerted by the gas. See, let's see, this is the container. We took some container and some gas is present inside. So this gas, how much amount of pressure this gas exerts, that is called pressure in this equation. And volume is nothing but, volume is not volume of the given gas. That's why I am explaining about pressure also carefully. Volume is volume of this container, total container. Volume of total container here V refers to, and N refers to number of moles of gas. R refers to universal gas constant, which is R is nothing but 0.0821 liter atmosphere per Kelvin mole. Hope this is the standard thing. Universal gas constant. Right. 0.0821 liter atmosphere per Kelvin mole. This is universal gas constant units. Okay, you should remember it. It's pretty much useful actually. This is universal gas constant, and T refers to temperature, which is Kelvin, K. Okay, you are taking some gas container. Here let's say volume is constant and also given that temperature is also constant. In that case, pressure is directly proportional to number of moles of the gas. This is very much useful. Actually, we are having a question in base mole concept. That's why I've been explaining this one. So when if we took a container, and here volume and uh, temperature were fixed, that means were constant, then in this case pressure is directly proportional to number of moles of that gas. Okay. This is what about ideal gas equation. Next, mixture analysis or mole fraction. A, B, C. Let's say three substances were present, A and B and C. Mole fraction is represented by chi. See this one, it's like x actually, chi, which means number of moles of A by number of moles of A plus number of moles of B by number of moles of C. Number of moles of mole fraction of B means number of moles of B by number of A moles of A plus B plus C. Oh, okay. And as usual for C also. This is what mole fraction is. Mixture analysis means, let's say you can understand it clearly by just reading this word. Everybody could understand by reading that English. See, some here some mixture is there. We have been analyzing this. That means in this mixture there are three substances, it seems, A, B, C. Then we were asked to find out mole fraction of A. Mole fraction means here mole fraction. Mole fraction is represented as chi A, which is number of moles of B. See, number of moles of A by number of moles of total this mixture, which is number of moles of A plus number of moles of B plus number of moles of C. So in this way, mole fraction is calculated. Mixture, in this mixture analysis, first topic is taken as mole fraction, and also an important result is chi A plus chi B plus chi C is equal to 1. Okay. Yes, this is first one is mole fraction. Second one is mass fraction. Actually, these are not much important for saying main. So, but I will be explaining. See, mass fraction is nothing but, let's say A, B, C, three substances were present, and for A, weight of A is WA, weight of B is WB, weight of C is WC. Then mass fraction here, in before here we found out mole fraction. Here n refers to number of moles. Here, as it is same formula will be there, but here it refers to mass mass fraction. Okay. Yes, let's go further. Mole percentage, same here. First mole fraction, second mass fraction. Here mole percentage means mole percentage of A is given as mole fraction of A into 100. We will multiply it by 100. That's what mole percentage refers to. Okay. This is a basic level. Suppose you took a solution, it has solute and solvent. Here we were given that mole fraction of solute is 0.1. So by this you should be calculating number of moles of solute and number of moles of solvent. I'll explain you with see here. See, we were given chi of solute. Mole fraction of solute is given by 0.1. 0.1 is nothing but 1 by 10. That means 1 refers to number of moles of solute, and 10 can be written as 1 by 1. Here below conformly this number of moles of solute will be there. So 1 plus remaining how much? 10 minus 1, 9. So 1 by 1 plus 9, which means 9 refers to number of moles of solvent. So in the question, if we were given in this way, you can be and we are asked this is a very shortcut way, fancy way to know number of moles of solute and number of moles of solvent. Okay. In a solution, two types of things were present: solute, solvent. Hope need not to explain this. Solute and solvent. Solute means which solves in the solvent. See, let's take up the beaker, and if we it is of water, and we pour sugar. We are making sugar solution. Sugar settles down. Sugar settles down here. So here sugar refers to solute and water refers to solvent. Okay, and this is called sugar solution. So this is the most important thing you need for JEE mains, especially. See, percent m by m, percent w by w, percent weight by weight, percentage by mass. These all explain to you the same thing. Listen it carefully. Let's say percentage m by m was given. It means in the question we were given that 20% m by m glucose solution was taken in this experiment. See, in the question we were in there was a question in that question we were given that 20% m by m glucose solution glucose solution was taken in this experiment. That means you don't worry, which means which is nothing but 100 grams of solution, 100 grams of solution, in 100 grams of solution, glucose present in that 100 grams of solution is 20 grams. That is, weight of solute was given especially to maintain, to give it clearly. 100 grams, to say it in Telugu, 100 grams of solution lo 20 grams glucose ఉంటుంది. That's what it means. Okay, 100 grams of solutions has glucose is equal to 20 grams, which is nothing but mass of solute. That by this we can say mass of solvent, right? What mass of solvent is nothing but 80 grams, which is 100 minus 20. Okay, same refers to percentage weight by weight, percentage by mass, percentage mass by mass. Here anything is same in the question. In this three, any of the thing was given, then that meaning is in 100 grams of solution of that thing, the solute present is 20 grams. That is here in this example, in this particular example, 20 grams. Okay, this is all not needed for JEE, not at all asked up to till now, not at all useful also. See, there was a question. Let's solve this. Come on. NaNO3 weighed out to make 50 ml of an aqueous solution containing 70 milligrams sodium. See here carefully what we are asked. First try to understand the question. I'll tell you in Telugu. See clearly. NaNO3 weighed out to make this is sodium nitrate. Sodium nitrate 50 ml of aqueous solution containing 70 milligrams sodium per milliliter తయారు చేయడానికి ఎంత సోడియం నైట్రేట్ వెయ్యి అవుతుంది, అదే ఎంత అవుతుంది అంటే 50 ml ఒక aqueous solution ఉంది. ఆ 50 ml of that aqueous solution, to prepare that 50 ml of aqueous solution, 70 milligram sodium per milliliter యూజ్ చేస్తే ఎంత సోడియం నైట్రేట్ మనకు కావాలి, హౌ మచ్ డిడ్ ఇట్ వే అవుట్. ఓకే, సో ఫస్ట్ ఇన్ దిస్ క్వశ్చన్ 50 ml of aqueous solution containing 70 milligram sodium. Let's go onwards. Let's write all this. 50 ml 70 milligram sodium per milliliter. Okay, that means 50 ml. Give me a minute. This got stuck. What happened?